Good morning. Welcome to today's video. The topic I'll be discussing is nutrition. Nutrition would be in 3 or more videos. In this first video, I'll be talking about food substances. Beyond food substances, I'll talk about modes of nutrition, and then I'll go on to talk about digestion. Basically, we say nutrition is the process of organisms obtaining nutrients that they need for their bodily activities and for survival. Now, these nutrients are usually present in food. Now, food can occur in different forms. So usually we talk about the classes of food. Some persons talk about 3 classes of foods, some talk about 6, and then some others talk about 7 classes of food. Well, depending on what your question is, if you're asked for the 3 classes of food, then you're expected to mention these ones. Carbohydrates, proteins, fats, and oils. They are the 3 major classes of food. They are the types of food that we need in large amounts. So usually we refer to them as the macronutrients. That's different from macro minerals, something we'll talk about later. For now, we're talking about macronutrients, nutrients we need in large amounts. They are these 3. So some regard them as the only 3 classes of food. Then we have these ones, the vitamins, the minerals, and then water. These are also food substances. So some talk about the 6 classes of food, with the first 3 being the macronutrients and these ones being the micronutrients because we need them in just small amounts. Then of course we have what we refer to as roughages. Now for roughages, they are indigestible materials. Of these 7, we can digest the first 3 into smaller material. Then for these other 3, we don't digest them, but at least we can absorb them and use them. For roughages, they are not absorbed, neither are they digested. They are just in passing. They go through our digestive system, helping whatever is in the digestive system to move fast, to move quickly, and not remain, stagnant. So usually we say if roughages are missing in one's diet, excuse me, then a constipation could result. Now let's look at these in some small detail. Carbohydrates first. Usually they are referred to as carbs for ease. People just call them carbs. Now the carbs are in 3 classes. We have the simplest of carbs called the monosaccharides or single sugars. So the monosaccharides are also called the single sugars or simple sugars. And then we have another group we call the disaccharides. And finally, we have a third group that we call the polysaccharides. So monosaccharides, disaccharides, and polysaccharides. The disaccharides are also called double sugars, whereas the polysaccharides are also called complex sugars. However, it is better to refer to them as non-sugars. I'll tell you why. We call them non-sugars because they do not have the attributes of sugars. Now, what are the attributes of sugars? Sugars are usually sweet, sugars are usually soluble in water, and sugars are usually crystallizable. But for these ones, they do not have those properties. As such, we prefer to call them non-sugars. Now, the monosaccharides are of different types, but the most popular monosaccharides are the ones we call hexoses. And these hexoses have general formula C6H12O6. They are the most popular of all the monosaccharides. Now for disaccharides, we don't have them in different types. All disaccharides have a common formula, which is C12, H22, and O11. Then for polysaccharides, they all have the formula C6, H10, O5. So these are the formulas of the different classes of carbohydrates, mono, di, and polysaccharides. Now, two monosaccharides can join to form a disaccharide. That process would involve what we call condensation. Condensation occurs when two small molecules come together to form a big molecule, and then between them they lose a small molecule. That's like 10 plus 10 to form 20, but no, as 10 comes and 10 comes, 2 is lost, so that the total becomes 18. That's condensation. Similarly, when two monosaccharides come together, they form a disaccharide. Now you may notice that if C6H12O6 were to add on to itself, we should have C12H24O12. But see what we have here? It tells you that a water molecule has been lost, and that's condensation. Then if more and more of these monosaccharides join to the disaccharide unit, a time comes when we have the polysaccharide. Now, the monosaccharides, what are examples of them? We have things like glucose, fructose, and galactose. So glucose, fructose, galactose are monosaccharides. For the disaccharides, we have examples like maltose, sucrose, and lactose. Then for the polysaccharides, the commonest examples are starch, glycogen, and cellulose. All of these are examples of polysaccharides. Now for the disaccharides, it's interesting to note that when glucose joins with itself, that is two glucose molecules together, we usually obtain maltose. Then when glucose combines with fructose, we get sucrose, and then glucose with galactose, we get lactose. So that's how monosaccharides are able to join to get disaccharides. Now beyond this, if you look at the formula, this is the last on carbohydrates. Look at the formula of monosaccharides, you see that we have CH and O in the ratio 1:2:1. Is that the same for disaccharides? No. But what we see across board is that the ratio of hydrogen to oxygen remains 2:1. 12:6, 2:1. 22:11, 2:1. And then 10:5, 2:1. So it may be very important to note that the general formula for carbohydrates is CXH2OY, which is the same as CXH2YOY. So usually we talk about carbohydrates as compounds that contain carbon, hydrogen, and oxygen, with the hydrogen and oxygen being in the ratio 2:1. Let's say a word on proteins. Proteins are also macromolecules, and they are built from smaller molecules called amino acids. So just as we have our carbohydrates, our polysaccharides being built from monosaccharides, proteins, giant molecules, are built from smaller molecules called amino acids. Now the structure of amino acids cannot be discussed at this level, but subsequently we'll get to know much about them, especially in the advanced levels. But for now, these amino acids build proteins by the same condensation. Like I told us here, that monosaccharides become polysaccharides by condensation. Now, what if proteins were to become amino acids again? That would be the reverse process, and it will occur by what we call hydrolysis. So protein to amino acids, hydrolysis; amino acids to proteins, condensation. Just as mono to poly, condensation, and then poly to mono, hydrolysis. Now, proteins are very useful in the human body, especially, or bodies of animals, for the purpose of bodybuilding, tissue formation, tissue repair. Unlike carbohydrates that are mainly for energy, we break them down for our energy requirements. Now, there are different examples of proteins. I'd like to differentiate between examples of proteins and sources of proteins. For example, milk is not a protein. Milk is a source of proteins, and the protein in milk is called carcinogen. Remember that in milk there's also carbohydrates, like this lactose. Lactose is present in milk. So milk is a source of proteins just as a source of carbohydrates. It is not in itself a protein. What about eggs? In eggs you have a protein called albumin. So albumin is a protein found in egg. Then beyond eggs, in flour, you can have what is called gluten. And then in blood, you can have some proteins including fibrinogen. What else now? You can have globulin. And you can have this one, interestingly, albumin. Now, albumin looks so much like albumin and must not be confused. Albumin in eggs, but albumin, a transport protein found in blood. So these are examples of proteins as opposed to sources of proteins. Then beyond the proteins, fats and oils. Some persons refer to fats and oils as an alternative term for lipids. Well, that's not very correct because the term lipid includes fats and oils and a large other number of compounds, like the fat-soluble vitamins. They are also regarded as lipids. So lipid, fats and oils are not exactly synonyms. Now, for the fats and oils, generally, fats are solids at room temperature, whereas oils are liquid at room temperature. So it means that under suitable conditions, oils can be solidified so that they become fats. Also, fats are usually of animal origin while oils are of plant origins. But yes, there are some oils that may be obtained from animals, such as fish. We have fish oils and some other forms of oil. Now, the fats and oils are complex molecules built from fatty acids and glycerol. So the fatty acids and glycerol come together by condensation to form fats and oils, and fats and oils can be hydrolyzed to give us fatty acids and glycerol. So it's practically the same thing, going from simple to complex by condensation and from complex to simple by hydrolysis. Now, fats and oils can also provide energy, just like the carbohydrates. And then they can be found in certain areas of the body, like under the skin, where they serve a very important purpose in the process of insulation and temperature regulation. Now, beyond these three, the macro nutrients, for the micronutrients, water is a medium. In fact, we say that 70% of the human body is water, and that means we need water for practically everything. Most of the reactions that occur in our body occurs in an aqueous medium. So the aqueous medium, being water, is very important for several reactions to occur. Enzymes will not function in the absence of water, so water is vital. Even digestion, in the absence of water, digestion would practically be impossible. So water is required basically for reactions occurring within the body and to maintain the overall composition of the body. For the minerals of two basic types, they are the ones we call macro minerals and micro minerals. Now that's different from macronutrients and micronutrients. We already said the macronutrients are carbohydrates, proteins, and lipids, whereas the micronutrients include vitamins, minerals, and water. Now, the minerals themselves can be macro minerals, the ones we need in large amounts, or micro minerals. And most of these minerals function as coenzymes or components of the different enzymes, the organic catalysts we have within our body. Examples of macro minerals, large amounts, are things like calcium, you have phosphorus, you have potassium, you have sodium, then you have chlorine, it's also an example. Then for the micro, the ones we need in small amounts, usually you find them in food, supplementation purpose, and all the things like iron, iodine, fluorine, are all examples of micronutrients or micro elements rather. Now, having mentioned these micro minerals, we will move on to talk about vitamins. Now, for vitamins, we'll be interested in just two major things. For each of the vitamins I'll mention, we're interested in their names and we're interested in what happens when they are missing in one's body. So I'm going to list the different common vitamins we have and tell you what happens when we don't have them. Now, vitamins are broadly classified into two. We have the ones we call fat soluble, and then the ones we refer to as water soluble vitamins. For the fat soluble vitamins, they are called fat soluble because they are not soluble in water. So in the human body, they are not excreted through the kidneys. Yeah, the kidney makes urine, and urine has water as its major component. So anything to be lost from our body through the urine must be water soluble. But for the fat soluble vitamins, they can only be lost from our bodies through bile. And that also means that it may be easier for us to handle the water soluble vitamins as we produce urine very rapidly, as opposed to the fat soluble vitamins, which may take a longer time and more effort. Now, the fat soluble vitamins are just 4: A, D, E, and K, whereas the water soluble vitamins are 9: vitamin C, and then the 8 B vitamins, which are B1, B2, B3, B5, B6, B7, B9, and B12. So there are 8 B vitamins as I have listed here. Now, vitamin A, being the first fat soluble vitamin, is also called retinol. And if you don't have retinol, you think about a part of the body called retina, yes, in the eyes. When one does not have retinol, then problems in the eyes are very common. One of these problems is xerophthalmia. Xerophthalmia means dryness of the eyes, inability of an individual to produce tears. It occurs due to a deficiency of vitamin A, but more importantly, we have what is called night blindness. Night blindness can be a genetic condition actually, but night blindness generally is said to be due to deficiency of vitamin A. The individual does not have vitamin A. As a result, he is unable to synthesize what we call rhodopsin or visual purple, which helps us to see in the dark. So in the absence of vitamin A, no rhodopsin, and in the absence of rhodopsin, there's inability to see in dim light, in dark places, not necessarily at night. It can be during the day, but in a dark environment. So that's night blindness. Deficiency of vitamin A leads to that. Vitamin D, when absent in a child, can lead to rickets, but when absent in an adult can lead to what is called osteomalacia. Now, the name for vitamin D is calciferol. Calciferol is vitamin D. Now, for vitamin E, it is called tocopherol. When there's lack of tocopherol, it can lead to infertility, especially in birds, not necessarily established in humans. And then in humans, there can be neurological disturbances, problems with irritability, and so on. Then for vitamin K, it is called phylloquinone. You see, in the advanced level, you'll be told about phylloquinone, menaquinone, vitamin K1, K2, and all of that. But at this level, just know that phylloquinone is the name for vitamin K. Now, what happens when we lack vitamin K? We'll easily understand that if we know the function of vitamin K. Vitamin K usually activates the blood clotting factors. So when vitamin K is missing in a person, then blood clotting factors may not get activated, and that means that a person's blood would not clot when it should. So they will come to the hemorrhage, which is bleeding disorders in people with vitamin K deficiency. Now for vitamin C is called ascorbic acid. Ascorbic acid, and this ascorbic acid is very important for tissue formation of the gums, formation of the skin, formation of the walls of the blood vessels. Whenever you have collagen, you need vitamin C for proper collagen formation. So where vitamin C is missing, the skin bruises easily, the gums will bruise easily, individuals brush and they see blood coming out like that. It could be due to vitamin C deficiency. And then the walls of the blood vessels become friable, they break easily. And when that happens, there can be internal bleeding. All of these problems are summed up in one word, and that word is scurvy. Scurvy is a very deadly condition, actually, if not treated. So scurvy is due to a deficiency of vitamin C. Then for vitamin B1, it is called thiamine. Vitamin B2 is called riboflavin. Vitamin B3 is called niacin. And B5 is called pantothenic acid. Now, these four vitamins act as coenzymes in the respiratory process, in the process of respiration. And of course, respiration provides energy for us. So if they are missing, any of them missing, we expect that there will be abnormalities in the respiratory process, and that means there could be fatigue, which is weakness. But apart from that general effect of fatigue, the first three have other effects that we can mention as part of what happens when they are missing. For B1, we mentioned the condition called beriberi. For B2, we talk about sore mouth, sore throats, scarring of the angles of the mouth, what we call angular chiliosis or stomatitis. And then for B3 deficiency, there's what we call pellagra. So pellagra occurs when there's niacin deficiency. Then the remaining four, you've noticed that there's a good relationship between 6, 9, and 12, like 3 as a common difference. So 6 plus 3, 9, 9 plus 3, 12. Now vitamins B6, B9, and B12 have a common deficiency defect, which is anemia. So in the absence of B6, there's anemia. In the absence of B9, there's anemia. Absence of B12, there's anemia. Now the anemia of B12 is most severe. So usually we refer to it as pernicious anemia. Then, okay, let me put that here. So when you hear of pernicious anemia, pernicious means harmful. So harmful anemia, that's B12 anemia, because it doesn't stop at anemia. It also leads to neurological problems, disorders of the brain, and so on. Then B7. B7 used to be called vitamin H. So if you hear of vitamin H in any text, vitamin H is what we know today as B7. Its name is biotin. Now, a deficiency of biotin will lead to dermatitis. So dermatitis occurs, some inflammation of the skin, actually. It occurs when there's deficiency of vitamin H. And in some persons, what leads to deficiency of vitamin H could be due to an overconsumption, a consumption of large amounts of raw eggs, because raw eggs contain a substance called avidin, and this avidin is able to bind vitamin B7 and make it unavailable for the body's use. Just before I forget, I will list the names of these three. B6 is called pyridoxine. B9 is called folic acid. And B12 is called cobalamin. Now, cobalamin is called cobalamin because it contains a heavy metal, cobalt. Not exactly a heavy metal, it's a transition metal. So from cobalt, we have cobalamin. Cobalamin can come in different forms like cyanocobalamin, hydroxycobalamin, methylcobalamin, S-adenosyl cobalamin, different forms like that. So that's vitamin B12. So in the next part of this video, I'll be talking to you about types or modes of nutrition. So autotrophic, heterotrophic, and so on will be in the next video. Thank you for watching this.